Hello, this is Mr. DeArmond again, and I will be working with you on your fifth grade math lesson again this week. If you look at your packet, you'll notice that your page looks a little different because you only have one page this week. We are not doing a math and action lesson for week 3. We're doing some fluency practice. As a fifth grader, you are responsible for knowing this standard: fluently multiply multi-digit whole numbers up to 3-digit by 4-digit factors using appropriate strategies and algorithms. So let's take a second and break that apart. This is something you did earlier in the year with your teachers. This actually happened in Unit 1, the same unit I reviewed with you a couple of weeks ago. Obviously, this standard is about multiplying, and it says multi-digit whole numbers. We notice in parentheses that these numbers get pretty large because we're doing 3 digits by 4 digits, all right? It asks you to use appropriate strategies and algorithms, and you've learned lots of strategies for multiplication. But as a fifth grader, we're starting to move away from those strategies that you learned in like maybe third grade and pushing you more towards working with the standard algorithm. And that's because these numbers are getting larger and bigger, and it's just not as easy to use some of the other strategies. All right, so that brings me to our discussion on what does it mean to be fluent. All right, so to be fluent, you have to be flexible. So you have lots of tools in your toolbox, and being able to take those tools, those strategies, and use them at the appropriate times to tackle a variety of problems, that means you're flexible. But you also have to be efficient, and that's why I talked about pushing you to use the standard algorithm over maybe some of the other strategies, because when you get to those bigger numbers, it might not be efficient to draw out a area model. Also, if you don't have pencil and paper and you're trying to do some mental math or something like that, other strategies are better than certain ones that require paper and pencil. And the last part about being fluent is being accurate. You do have to get the correct answer. And so being able to do that makes you fluent. All three of those things together: being flexible with a variety of strategies, being efficient, knowing which strategy to choose for which problem, and being accurate, finding the correct answer. Now, I did want to do a quick review for you about our strategies for multiplication. So I took the problem 128 times 35, and over on the left, you'll see I used the area model, breaking apart my first factor, 128 across the top, breaking apart the 35 here on the left, multiplying each of those, getting all those answers, adding them up to find 4,480. Again, that strategy you learned to start using in third grade when you were doing multiplication. We also did partial products. So 128 times 35 here, I broke it apart into some smaller problems: 128 times 5 and 128 times 30. And I was able to find my answer again, the exact same answer I found with the area model. I did make a note here about the distributive property. Anytime we're thinking about multiplication and we see something in parentheses, that could clue you in to think about using the distributive property. All right, the distributive property, if you'll remember, is when we take one of the factors, we bust it up by place value, and we distribute it out to be able to be multiplied by the other factor. All right, it just makes it a little bit easier sometimes. So here, when I busted apart the 30 and the 5, right, 35 and now times 30 times 5, I use the distributive property. All right, and we're going to talk a little bit more about that in a little bit. Again, the last strategy we're going to talk about today is the standard algorithm. Again, that's a fifth grade thing that we're trying to teach you this year to be more efficient with that, because you're going to need that as you continue on through school and through math. All right, so here the standard algorithm looks very similar to what I just showed you with the partial products. It's really closely connected, and it's a progression from the area model to the partial products to now being able to use the standard algorithm. All right, your parents might call this the old school approach, or this is the way that they learned it. This is the way that I learned it when I was in school. This is the way your teachers learned it when they were in school. All right, so now as fifth graders, we're teaching you the way that we all learned it. And again, it's called the standard algorithm, because that is a little bit newer to you this year versus the other strategies that you used in third and fourth grade. I will take some time today to actually work through a problem with you just to model that again, okay? All right, as I said, we only have 5 problems to do this week. If you are at home and able to pause the video, maybe you're watching on the computer or something, and you can pause the video. After I talk about each problem, I'm going to remind you that you might want to pause and work it out on your own, and then you can join us back and check your answers. If you're watching with me on TV and you can't pause this, then I am going to go through all the problems. I'm going to show you my work. You probably will not have time to write down everything that I do, but so we're just going to treat this as a quick review. You might want to take a few notes as you're watching, and then you can go back and work out the 5 problems after you've watched all the stuff that I've done, all right? So I'm going to give you the answers, but then you can go back and work it out and make sure you can find the correct answer, okay? All right, so problem number 1. Todd can drive 235 miles on 1 tank of gas. How many miles can he drive on 14 tanks of gas? Well, one trick with word problems is that we have to figure out what operation we're doing. Now, I'm going to give you a little secret today because our standard is all about the fluency and multiplication. We are doing all multiplication today, all right, or this week. So it's all about multiplying. But I do want to point out to you some ways to figure that out when you don't know what operation you're going to do. So we're thinking about this problem. I know that Todd can drive 235 miles on 1 tank, all right? They asked me how to do 14 tanks. Well, I could take 235 for 1 tank, 235 for 2 tanks, 235 for the 3rd tank, and so forth, and add those all together to find my answer. But that's going to take too long. So this is going to be a multiplication problem. 235 times 14, that's a lot faster. So instead of doing that repeated addition, we make this multiplication. All right, so if you're at home and you want to pause, I chose to do an area model for this problem. So you might want to pause and try to do the area model or try to use one of the other strategies to see if you can come up with the answer. Here is my work. Again, I chose to use an area model. I split apart at the top, my first factor, 235. Again, I broke that apart by place value, or we'd say in an expanded form. Over here on the left, I used 14, or 10 and 4, and I was able to do my multiplication. Now, the first row is pretty easy to fill out because we all used to use the power of 10. So 10 times 200 is 2,000, 10 times 30 is 300, 10 times 5 is 50, all right? Pretty easy, again, just using that power of 10. The second row, if you know your basic multiplication facts, again, it's pretty quick. 4 times 200 is 800, 4 times 30 is 120, 4 times 5 is 20. And I come over here and add them all up together and find my answer, all right? That's the product to our problem, 235 times 14. Now, I do have to point out to you that I made a big mistake, and your teachers would be really mad at me if I didn't point this out. I did not label my answer, all right? I just wrote down a number, 3,290. Remember, when we're working with word problems, we have a context that we are working in, and we have to include a label in our answer. So in this problem, we were talking about how far Todd could travel on 14 tanks of gas. So my answer should have been 3,290 miles. So if you did that at home, give yourself a pat on the back, or if you messed up like I did, you might want to make sure you label that 3,290 miles. That's how far Todd can go on 14 tanks of gas. All right, problem 2. It says choose yes or no to tell whether the expression is equivalent to 427 times 35. Now that word equivalent, just as a reminder, means it has to be the same as, or it has to be equal. So we're looking at 4 choices down here, and we're trying to figure out which ones are equivalent or equal to 427 times 35. Now, when I look at my choices down here, I see that I have to mark either yes or no about whether it's equivalent. And I see that B, C, and D look very similar to me. They all have parentheses and multiplication and addition. I know this is a multiplication problem, and I see we're multiplying, but we're also adding, and we've got those parentheses, those grouping symbols. And when I see that, as I mentioned earlier, anytime we're multiplying, we see parentheses, we might want to remember the distributive property, right? And that's basically what they're doing in letters C and D and B, is using the distributive property, all right? If you're at home and you want to pause the video, you can work through these 4 answer choices, decide what is equivalent and what's not, and you can join this back. All right, so I decided to look at B, C, and D first because, again, they all look very similar, look very different than letter A. And so C and D, again, I saw parentheses, so I'm thinking, okay, this could possibly be the distributive property. So I'm going to take our problem, 427 times 35, and I'm going to use the distributive property to work that out. So on the left-hand side, I took the first factor, 427, broke it apart by place value, so 420 and 7, and I multiplied each one of those digits, or sorry, not digits, those place values, those factors by 35, which was our second factor in the problem. So 400 times 35, 20 times 35, and 7 times 35. I was able to come up with an answer for each set of the parentheses, put it all together to get 14,945. Now I also did the distributive property on the right-hand side, but this time I did a little differently. I kept the first factor the same. 427 is in both sets of parentheses, but I broke apart the second factor. I multiplied the first one by 30, multiplied the second one by 5, and that's the distributive property. Breaking apart the factor, splitting it up so that it can be multiplied out or distributed to be able to multiply a little bit easier, okay? I found the answer for each set of parentheses, put it together, ended up with the exact same answer as I got with the first way I did it. Both ways of using the distributive property to break up the factors gave me 14,945. Now, the problem didn't ask me to find the actual answer, asked me to look at some answer choices to see which ones were equivalent. So I want you to pay attention to what I did here, using the distributive property, breaking apart the first factor, multiplying by the second factor, or keeping the first factor together and multiplying by the second factor broken apart. And let's go back and look at our answer choices. In letter C, I see they took 427 times 30, 427 times 5, which gives us 35 when we put it back together. So letter C is equivalent to that original problem of 427 times 35. They just busted apart that second factor. Letter D, I see that they split apart the first factor, 420 and 7, and multiplied each of those by that second factor of 35. So it also is equivalent. Now looking at letter B, it looks very similar to letters C and D, but I am not sure if it's the same or not. So I went ahead and used my distributive property again, like they've written out, and I found my answer. So I took 427 times 3, 427 times 5, but this time my answer was 3,416, which is not the same as the two answers I got up here. So letter B is not going to be equivalent. It is no. Can you tell me why, by just looking back at letter B, why it's a no? They kind of put them together, B and C. If you compare B and C together, we know C was yes, but B is no. And if we look at it, the only thing I see different is right here. They multiplied 427 times 3 and not by 30. When we go back to our problem, 427 times 35, they multiply by the digit 3, but really they should be multiplying by 30 because the 3 is in the tens place. So letter B is a no. Now thinking about letter A, again, it looks very different from B, C, and D. You know that C and D are yes, but letter A, there's no parentheses, so I'm not thinking distributive property anymore. But I do see that we're adding all those numbers together, and there's one number for each place value. I have something in the 10,000s place, the thousands place, the hundreds, the tens, and the ones. That makes me think about expanded form. And going back to what we figured out our answer was when we multiplied 427 times 35, we got 14,945, and that's what they did in letter A. They're breaking apart the answer, the product, into expanded form. And so yes, the value of 10,000 plus 4,000 plus 900 plus 40 and 5, the value or the sum there is equivalent to 427 times 35. So in letters C and D, they showed you how to break it apart to multiply. In letter A, they took the answer, they took the product and busted it apart in expanded form. So A, C, and D are all equivalent to 427 times 35. All right, this is number 3, and it's asking us to find the product of 3,614 times 272. Now, here's one where we're meeting the full extent of the standard. This is a 3-digit by 4-digit multiplication problem. That's the extent of what you're supposed to do as a 5th grader. Now, for this problem, because those numbers can get pretty big, I chose not to do the area model, but to use a standard algorithm, or the standard algorithm, all right? That new approach we've taught you this year as 5th graders. So if you're working at home and you want to pause the video and work that out using the standard algorithm or any of the other strategies that you're comfortable using, you can. I'm going to go ahead and I'm actually going to walk through this problem step by step because, again, the standard algorithm is new to you as a 5th grader. I wanted to make sure you knew how to do it. So I'm going to try to work that out for you and show you how I would do it using the standard algorithm. I do need to warn you that I am using my mouse on my computer and it does get a little bit hard. So some of my writing could be a little bit messy, okay? If you'll just bear with me. Some of you probably have your teacher's active pens or active board stuff go out and they also have to use their computer sometimes. So if you'll bear with me, I'm also going to use different colors so that we know what's going on. Now I'm going to start by multiplying by my 2 in the ones place, all right, the digit 2. And I'm going to say 4 times 2 is 8, all right? Then I need to multiply 2 times what's in the tens place. So 2 times 1 is 2. Well, we're not really doing 2 times 1. We're actually doing 2 times 10 because that 1 is in the tens place. So 2 times 1 is actually 20. If I look at that number, it is there in the tens place, so the number 20. Then I'm going to multiply 6 times 2, which really is 600 times 2. Well, 6 times 2 is 12. But 6 times 2 is 1,200. So really that would be 1,200, but I can only put 1 digit in each of my place values. So that 1,000 has to come up here above the 3,000. And I'm going to multiply again. I know that 3 times 2 is 6. This is 3,000 times 2, so it's actually 6,000 plus the extra 1,000 I brought over makes it 7,228. And that's multiplying the first factor by the first digit, my 2 in the ones place, all right? Now, again, this is very similar to what you've already done with partial products. I took the first factor and multiplied it by 1 piece of my second factor. All right, now we're going to look at the 7. The 7 is in the tens place, so we're multiplying everything not by 7, but really by 70. So that means I have to put a placeholder down here because I'm not multiplying by 7 because it's not in the ones place, I'm multiplying by 7 in the tens place. So now I can do my multiplication. 7 times 4, if I think about the digits, 7 times 4 is 28. It's a basic multiplication fact. All right, or 70 times 4 is 280. So I've got an extra group of tens I'm going to put up here. So 7 times 1 is 70, plus 2 more is going to be 9. All right. Then I'm going to multiply 6 times 7, which is 42. And again, I can only write down 1 digit. So the 4 is going to have to come up here. And I'm going to do 7 times 3, which is 21. I'm going to add in the extra 4, which is actually 25. Again, that was actually, I did the digits, but we're actually multiplying by 70 times 600, 70 times 3,000. We end up with 252,980 for that partial product. And multiplying everything by 70. Now we're going to multiply everything by the 2 in the hundreds place, or by 200. So now that we're multiplying by hundreds, I'm going to have 2 zeros down here to mark that we're multiplying by 200 and not just by the number 2. So 2 times 4 gives me 8. 2 times 1 is 2. 6 times 2 is 12. Again, I can only write down 1 digit, so that extra 1 is going to come up here. 3 times 2 is 6, plus the 1 more gives me 7. All right, so when I did my partial product of 3,614 times 200, I got 722,800. And now, with basically all my partial products there, I'm going to add them all together. So 8 and 0 is 8. 8 and 2 is 10. I have to bring up 1 right here. I can do 9 and that 1 makes 10. 8 more is 18. Plus 2 more is 20. So bring the 2 up here. I'm going to do 2, 4, 6. All my 2s. Then 6 and 7 makes that 13. Sorry, that 3 looks a little messy. I can do 5 and 2 more is 7, plus 1 more is 8. And then 7 and 2 is 9. So my product is 983,008. Now, again, that's a little messy because I was trying to write with my mouse. So I want to actually show it to you. I've already worked it out. And I'm going to show it to you right here. There it is on paper where it's a little bit neater. So we get our answer, 983,008. And I made a little note over here to show you. Again, I did it with colors when I worked it out for you just now. But over here, you can see I took 3,614 times 2, 3,614 times 70, 3,614 times 200. Basically, again, that's partial products, which is stuff you already know how to do. All right, but that's the way we would do it with the standard algorithm. All right, problem number 4 says the factory receives an order to ship at least 45,000 parts. Which shipments contain enough parts for this order? Mark all that apply. So down here, I look at my answers. I've got 315 boxes of 144, 270 boxes of 164. I need to multiply all of these out to see which ones will give us enough parts to fulfill this order. So if you're working at home, you might want to pause the video and take A, B, C, and D, each one of them, and actually multiply it out to find the answer. Now, when I did it, I went ahead and did the standard algorithm again, just because these numbers are getting bigger. We had a 3-digit by 3-digit, and it's a little bit quicker than maybe drawing out the area model. All right, so here's A and B. I multiplied 315 times 144, got 45,360. Multiplied 270 times 164 and got 44,280. Again, that's letters A and B. Now we go back to our problem. We know we're looking for 45,000 parts. Well, letter A, I've got enough. I've actually got 360 more than I need. But in letter B, we do not have enough. We're only at 44,000. So here's letters C and D. Again, I multiplied it out using the standard algorithm. I got 45,580 for letter C. I got 45,600 for letter D. And again, thinking about having to get 45,000 parts, all of them worked except for letter B, which was only 44,000 and something. The rest of them had more than enough parts to fulfill that order. Okay, again, I did that one pretty quickly. Again, you want to go back and maybe use the standard algorithm, or if you can't do that, use one of the other strategies to make sure you get the correct answer and that A, C, and D all have enough parts to fulfill the order. All right, one more problem. Last one for this week. It says an office supply company ships 3,143 packs of paper to each of 198 schools. How many packs of paper did they ship in all? So each school gets 3,143 packs of paper. All right, so that's one school with that much, another school, another school, another school. Again, we don't want to add that all together. So we're going to make this a multiplication problem. We're going to take 3,143 packs of paper and multiply that by each school. All right, so times 198. Again, this meets the full extent of the standard. It's a 4-digit by 3-digit. So again, I chose to use the standard algorithm to complete this problem. If you're working at home, you want to pause and work it out, please do so now. Here it is when I worked it out. Again, as a quick reminder, I took the first digit here, the number 8, multiplied it by my first factor and got my answer 25,144. Then I took the 9, which was actually 90, multiplied that by 3,143 and got 282,870 right here. Then I took 100, multiplied that out, which if you'll notice there, I just ended up adding the 2 zeros for the hundreds place because it was 100. All right. added it all together to get my answer of 622,314. And I made another mistake. You see what I did? Forgot to label my answer. That could be 622,314 miles. It could be 622,314 feet. Remember, we got to look at the context of our problem. So here they're asking us how many packs of paper did they ship in all. So make sure you label your answer 622,314 packs of paper were shipped out to all of the schools. All right, 622,314 packs of paper. All right, so that is our last problem for this week. All right, again, you only have 5 problems to do for this fluency practice of multiplication. So if you were able to pause the video and work through those problems with me, then hopefully you were able to check your answers and see what you got correct. If you missed any of those, you might want to go back and try them again. If you watched it live with me and could not pause the video, hopefully you took some notes or made some, remembered some of the things you should do. And then now you can sit down and try those 5 problems on your own to see if you can do it. If you want some more practice this week, you can take any of the types of problems we did today. You can make up some new numbers and continue to practice with multiplication. Again, as a 5th grader, we want you to be fluent with multiplication before you go on to 6th grade. And so that's up to 4 digits by 3 digits. So push yourself to do some bigger numbers, some 4-digit by 3-digit multiplication this week to practice. Again, you can use all of your strategies. That makes you fluent, is being able to use all those different strategies. But sometimes choosing the right strategy can mean having to do the standard algorithm versus an area model or things like that. So if you usually use one strategy all the time, push yourself to use another one as you practice some of these problems. Or if you've not yet fully got down the standard algorithm yet, you might want to take some time and practice that this week. Okay, again, the standard algorithm is the old school way of doing it. So your parents know how to use multiplication in that way, and they know how to use the standard algorithm, so they can help you with that. Again, just keep practicing that multiplication. Thanks for joining us today. Hope you're all happy and healthy and getting your work done at home. Enjoy this week, and we'll see you soon.